In Chapter 9, we're going to discuss what are called conic sections. Our first conic section, covered in Section 9.1, is called an ellipse. We're going to begin with a definition for the ellipse. There are two formats for what an ellipse can look like. The ellipse can be turned this way so that it is longest from left to right, or it can be turned this way so that it is longest up to down. In both cases, we have an individual formula. Now, what I want to do here is call your attention to several things that are on the formula sheet, and I know that this can look a little overwhelming as we get started. Okay, so let's begin with our general formula. So we definitely need to know this formula here. And what I want to do is compare that formula to the formula here. Now, if you look at those two formulas, the only difference is the placement of the A and the B. Now, what we do know is that in both cases, and I have that written over on the side, in both cases, that A is greater than B. And so essentially what we're saying is that sometimes your larger number is going to be underneath the X, and sometimes your larger number is going to be underneath the Y. If your larger number is under the X, it's going to be turned this way, with the longer axis running across, like the X-axis. If your larger number is underneath the Y, the ellipse is going to be turned this way, with the longer axis being up and down, like the Y-axis. Another thing that we want to keep in mind is this smaller version of a formula, which we have right here. And notice that that is the same in both cases. So we have a formula that looks very similar to Pythagorean theorem, even though it's not quite the same. We have a formula that says a squared minus b squared is equal to c squared. And we're going to use that formula to help us find different values that we may not be given. We also want to keep in mind that the center value in both cases is going to be made up of the h and the k values, that the vertex points, which will be the end points on the ellipse, will be defined by the A. The foci points, which will be points on the inside of the ellipse, will be defined by the C. And the co-vertex points will be defined by B. Now, as we have in many cases, this is going to make more sense as we start to look at a problem. And so let's go ahead and do that. All right, so we have an ellipse formula, x squared plus y squared, and the denominators are 16 and 9, is equal to 1. So what I'm going to do with this formula to get us started is I'm going to take the formula, and note that on our formulas, we typically have a number subtracted off from the x and the y. All right, so I'm going to do that here, and that number would have had to have been 0. So I'm just going to write this kind of in an unsimplified form so we can see it a little bit better. And so what you want to realize is that if there's not a number subtracted off on the x and the y parenthesis, that number had to have been 0. Okay, so what that tells me then is that my center of the ellipse is going to be 0, 0. Now again, I'm going to go back and look at this. Remember that the center is made up of your h and your k. That's the number that's subtracted off inside the parentheses. So I know right now that my center point on this ellipse is going to fall at 0, 0. Okay, so now I want to keep in mind that the numbers underneath the parentheses are the A and the B, and the A has to be bigger. So I know that the larger value here has to be the a squared, and the smaller value has to be the b squared, which means that a has to equal 4. Okay, if a squared is 16, then a had to have been 4. And b has to equal 3, since b squared is 9. Remember the little formula that we highlighted in green. A squared minus b squared equals c squared. Let's use that formula now. So a squared minus b squared is equal to c squared. Let's plug in our a value and our b value. So I have 16 minus 9 is equal to c squared. So c squared is equal to 7. So c is equal to the square root of 7. Okay, so the next thing I want to do is I want to determine the turn on this ellipse. So I'm going to kind of box in our important information there, and then I want to think about how the ellipse is turned. So I'm going to go back again to my formula and I'm going to look. Remember that the a is bigger, and so if your bigger number sits underneath the x, it looks like this. If your bigger number sits underneath the y, it looks like this. In our case, our bigger number sits underneath the x, so we know that our ellipse is going to run from side to side. So center at 0, 0, and we know roughly that our ellipse is going to look something like that. Okay, now let's make it a little bit better. All right, so we know that the a value determines the vertex points. All right, so what I'm going to do is I am going to move 4 units over in both directions, since the a is 4, and this is going to be a vertex point. All right, so we know right now, and I'll fix my picture in just a minute, but we know right now that my vertex points are going to be the points 4, 0 and negative 4, 0. All right, remember that your foci points are defined by the c value. So my c value is the square root of 7. Now, you may need your calculator to accurately plot that. The square root of 7 is like 2.6. So if I'm going to place a foci point, I'm going to come over 2.6, which is going to put it maybe right about here. And I'm going to come over 2.6 in this direction. And I can write my coordinates for this as well. So my foci, I'm going to go over 2.6, or actually over the square root of 7, and up 0. And then I'm going to do the same thing coming back to the left. I'm going to go to the left, a square root of 7, and up 0. So there are my foci points. Recall that your co-vertices, which define the shorter direction of the ellipse, are defined by b. All right, so our b value is 3, and so what I'm going to need to do is I'm going to need to mark off 3 up and place a point, and 3 down and place a point. Now, I'm going to go and I'm going to fix my ellipse. At this point, I should be able to draw it a little more accurately. It's going to come through that vertex, come around through that co-vertice, up and around. All right, so our problem asks us to determine the foci of the ellipse, which we did that here, and then graph the ellipse, which we have done as well. Now, I'll go ahead and show you the picture that they came up with, just so you can see a little neater picture, but it's exactly what we came up with. We have our 2 foci points, we have our 2 vertex points, and we have our co-vertices. And I guess the only thing that we didn't do was write down those co-vertices, so we can do that as well. Those points would be over 0 up 3 and over 0 down -3. And that produces that ellipse. Now, the next thing that they're going to do is define for us what is called the major axis and the minor axis. Now, we've really already looked at that. We just didn't necessarily call it that. So let me just show you on our picture. Our major axis is going to be the axis that runs, the longer one. It's going to run through the vertices and through the foci. All right, so here our major axis is going to run across. Here our major axis is going to run up and down. And the minor axis will be the other one. All right, so we can look at their definitions. They say that the major axis is the line segment extending from one extreme point of the ellipse to the other and passing through the two foci and the center. The major axis has a length of 2a, and the two ends of the major axis are the vertices. So they're saying that it goes through the vertices, it goes through the center, it goes through the foci, and the length is 2a. The minor axis is the line segment that passes through the center and is perpendicular to the major axis. It spans the distance between the other two extremes of the ellipse, and it has a length of 2b. Okay, so let's look at a second example. So we have an ellipse formula that we were being asked to graph. All right, so let's go ahead and take a look at this one. Let's write down what we definitely know. We can pull out the center relatively easily. So our center is going to be, now the easiest way to deal with your center, since you have to look at the opposite of each number. If you notice here in the formula, it's minus h and minus k, but the center is positive h and positive k. So the easiest way to pull your center is to do the opposite of the number that you see. So if you're looking at this and you see a -1, then in your center you're going to put a +1. If you're looking at this and you see a +4, then in your center we'll put a -4. Okay? So that'll take care of our center. Remember that your A is bigger than your B, so we're going to look at our two numbers on the bottom, and we can deduce that the A squared is the 25, since that's the larger number, and our B squared is the 9, which means that A had to have been 5, so that when we squared it, we got 25, and B had to have been 3, because when we squared it, we got 9. Now again, we can use our little formula, a squared minus b squared is equal to c squared, to calculate a c value. So I'm going to put the 5 in for the a, the 3 in for the b. So we'll have 25 minus 9 is equal to c squared. So c squared is equal to 16. So c has to equal 4. All right, and so now we have kind of our basic information there for our second example. All right, so let's go ahead and identify the turn. Remember that if your larger number sits underneath the x, it turns long ways from side to side. If your bigger number sits under the y, it turns up and down. So again, just like in our first example, our larger number is underneath the x. So we know that when we draw this, all right, I'm going to go ahead and plot my center point. Okay, so there's my center at 1, -4. Now I know that the ellipse is going to turn this way. Okay, so let's go ahead and work on finding our foci and our vertices and our co-vertices, and then we'll be able to draw the ellipse. So recall that the vertices come from the A value. All right, so on my graph, put a few more tick marks. What I need to do is I need to count over from the center in both directions 5 units, because the A is 5. All right, so I'm going to kind of line up with these tick marks at the top. So that's 1, 2, 3, 4, 5. Okay, so here's a vertex point, and let's write down coordinates as we go. So that is the point 1, 2, 3, 4, 5, 6, and -4. All right, and then we're going to come back and do the same thing in the other direction. So we're going to count over 5 in the other direction. So that's 1, 2, 3, 4, 5. All right, and so that's going to be the point 0, 1, 2, 3, 4, -4, -4. Okay, so I'm going to go ahead and just kind of clean this up a little bit so that we can see what we've got. That point on there. Vertex, vertex. All right, so now we can do the same thing for our foci points. So that, remember that comes from the C. And so we're going to go over 4 units in each direction. 1, 2, 3, 4. And we'll place a focus point here. That's going to be the point 5, -4. And we're going to do the same thing back in this direction. So 1, 2, 3, 4. So that's going to be the point -3, -4. All right, and then our co-vertices will be the B value. And so we will want to come up the other way. So 1, 2, 3, there's a co-vertex right there. And that's going to be at the point 1, -1. And then we're going to come down 3. So 1, 2, 3, there's your other one. That's going to be at the point 1, -7. And so once you get those points labeled on your graph, then you can actually come in and connect from the co-vertices to the vertex and back around, and then do it again on the right hand side, and you have a picture of your graph. And again, we'll look at the picture that they drew, which is just a little bit neater, but we can see that we have exactly the same picture as we just drew with our 2 vertex, our 2 foci, and our 2 co-vertices.